Hello everyone and welcome to this new series on digital electronics. In this first video, we will be going to talk about what digital signals are and why they are useful and how they are better than analog signals in many ways. So you will also get a basic idea of how we can convert signals from analog to digital and digital to analog. So this is just the beginning in this playlist. We will be going to learn everything from logic gates to combinational and sequential circuits and much more step by step. So stay tuned and let's begin our journey into the world of digital electronics. So let's start with the introduction to digital electronics. So first let's see what is meant by digital electronics. So in our day-to-day life we are using computers, laptops, mobiles or any electronic device. So these electronic devices are all working on the basic principle, so that is based on zeros and ones. So these zeros and ones are known as binary digits. These are the heart of the digital electronics. It all starts with the microchips or very small the gates, what we call. So many gates combinedly forms a microchip. So these microchips are again used in the computers as well in other electronic devices. So these studying of these circuits is known as digital electronics. So we are working on the digital means systems. So that is electronics hardware. So that is why this is known as digital electronics. So these are the digital systems or digital based on digits it works. So it is known as digital electronics. So digits means zeros and ones. So is there any other electronics other than digital electronics? Yes, we have another electronics, that is analog electronics. So what is meant by analog electronics? So basically digital electronics works on the just zeros and ones, but analog electronics works on the infinite set of points. So it can take any value. Suppose if you take a speaker, produces a large sound which can hear by many large crowds. A single person, a simple voice will be produced in the mic. It is just amplified with the help of op-amp or amplifier circuits. So these circuits are known as analog electronics. This will amplify or increase the sound of the individual persons and send to the speaker, and speaker will produce the more sound. So this is known as analog electronics. Basically this process is known as amplification. Amplification involves electromagnetic waves, sine waves. So these are like a type of sine analog waves, so that they can travel up to a very larger distance. So these have wavelength more, so as compared to digital square wave pulse. So because of this larger wavelengths, these can travel up to a very large distances. Not only this, we are using analog electronics in our mobile phones as well. So if you are talking a daily in your mobile phone, so your signal has to reach by cell tower. So this will be converted. So as you are speaking now, our voice will be recorded in our mobile phone. So in the digital data, that is in zeros and ones. So after storing, it will be coded as zeros and ones, and it will be amplified as a signal, analog signal, so that it will reach that cell tower. So after reaching cell tower, it will again modulate pulse. So again it will reach to our friend's phone. So our friend's phone will receive the analog signal only. So after an analog signal, my friend's phone will again decode the signal, the code which my phone has created. So his phone will be decoded that code. So again he can read properly in the form of digital data. So digital data will be seen by him, so that this conversion will be happen between both of. So in our day-to-day life, we are using our analog electronics very often, very usage. And not only just that, analog signals are everywhere, so naturally available analog signals only. This is what just I said, that is operational amplifier. So we will be going to see this full circuit and full information about this in upcoming videos. So let's start a simple comparison that between digital versus analog. So let's start with the analog. So let's understand what is meant by analog signal. A signal whose amplitude can take any value in the given range is the analog signal. So as you're seeing there, that is a sound signal. So you are seeing that it takes many points. So it is a wave one. So I represented it with the points. So the x-axis is time and y-axis is the function of the wave. On the wave we are taking some sample points, so that can be any of the point. So that is the wave that we are seeing. That wave is continuous. It can accept any point. Not only I kept points, in between points also allowed for this analog signals. Up to now we have saw what is meant by analog signal. So let's start what is meant by digital signal. A signal whose amplitude can take only finite number of values in the digital signal. So as you seeing there, it will only take. So as you seeing that is a bar. It's not a bar, it's a square graph, like a square pulse. So it starts with a 0 and it moves up to 5 voltage and it again comes to 0. 0 5 0 5 0 5. So this is the only square pulse wave. So it accepts only two values, whether 0 volt and 5 volt. So 5 volt and in y-axis and time in x-axis. So in our case, it is accepting only two values, that is 0 and 5 volt. So that is high and low voltages. So as I said earlier, in digital systems, we are going to use just only zeros and ones. So why even this is get into picture? So as you observe, in digital systems, we have only two terms. As a square pulse, we have saw the square graph as well in the before slide. So we have only high and low voltages. So this is the high voltage that we are seeing. So these high and low voltages can be represented as 1 and 0. So high voltage can be represented as 1 and low voltages can be represented as 0. So this is the reason why in the square pulse in the digital electronics as high and low, so we have to represent these two values as some values. So that is 0 and 1. So these zeros and ones are often very commonly used in digital electronics and digital circuits. So in the square pulse, we also have the low signal, that is 0. So 0 is corresponding to 0 volt and 1 is represented to 5 volt in analog signal. So as it is switching from only two values, that is 0 and 1 and 0. So 0 and 5 volt and 0 volt. So it is also known as switching circuit. So as you're seeing there, it's because switching from 0 and 1 and 1 to 0. So digital signals is also known as switching circuits. See, digital circuits are known as switching circuits. Let's see the advantages of digital systems over analog systems. So the first advantage is it is easy to store, replicate the process. So if you are performing some operations on zeros and ones, so you know the sequence of zeros and ones, so it is very easy to replicate the process. So if you are doing addition, so it is very easy to add two things because you know already the process. So it is replicatable. So it is easy to store also. So we have many devices like storage, 64 GB, 32 GB, we have many storages. So we can store very easily. So it is one of the main application of the digital systems then compared to analog systems. So analog signals are difficult to store. Why? The signals are not very easy to store. It has infinite set of values. So it is not easy to store them. It has very high accuracy, precision and reliability, because if we have some binary digit, so we can able to code and decode them, and we can able to read them very properly, very precisely, because we have ASCII values for everything. So with that ASCII values also we can able to perform, or we can able to know the actual digit in binary to decimal as well. So if you consider as 001, so that is 1. You know that 101, so in binary that is 5 in decimal. So likewise we have simple conversions. So we will be going to see these conversions in the upcoming videos. Just know it is high accuracy. Digital systems are very easy to fabricate in the big manufacturing companies. Like in the semicon industry, now we can see that the semiconductors has become to the nanoscale size. So those things are and all based on digital systems only. So this fabrication is easy, so that we are going to those much small size scales also. So these many advantages are there for digital systems. Then why we are using even analog signals? So basically naturally occurring the signals are only analog signals, and so analog signals are used to transfer the signals to a far distance, like I said in the before example, for a mobile communication. As I said that analog signals are available naturally. So if we speak also, it will be converted to analog. So computers can only understand zeros and ones. So because it can process only zeros and ones, so we need a conversion from analog to digital and digital to analog. For a simple example, we can say that is mobile communication. So within a second, fraction of seconds, this whole process is happening in our mobile phones. So these conversions, let's see as a quick overview of how this conversion happens. So let's start the conversion. So we have two types of conversions. So first one is analog to digital converter. So if you assume that we have an analog signal that is coming from our cell tower, so that we have to receive. So in our mobile devices we have called analog to digital converter, or simply we can say ADC. So these devices can able to convert the larger, or wavelength is larger, the analog signals to zeros and ones in the format of zeros and ones, the computer readable form in binary format, so that our microchips or our computer systems or our mobile phones can able to understand the signal, what is the signal message is sent. So in this whole process, the system or the digital systems are used is ADC, that is analog to digital converters. So this is also a vast topic, so we will be also going to cover this topic in upcoming videos. Okay, I got the signal. So again I need to send a signal or send a message to my friend. So how this can be happened? So basically in our mobile phone, all the messages and all the information is stored in the format of zeros and ones. Zeros and ones has to be converted as to analog form. So this conversion can be happened with the help of a device or system called DAC, digital to analog converter. This is also a vast topic. So in this concepts also we have many more applications. So many more systems and circuits we have. So we have to discuss these concepts in the upcoming videos. So after passing the digital zeros and ones to that, so it will be converted to analog signal back. So not the same signal that we have received. The information is different that we are sending. So the analog signal also different according to our information. So that's why I did not represent the same thing. So analog signal might be different thing, because the coming message and going message might be not be same. If same also, it need not to be same, because air resistance will be there and drag force in the air and according to the season, weather. So these are all considerations. I hope you understood the difference between analog and digital systems and circuits. So I hope you also understood the analog means the waves. So the waves are also very important. In this we have square pulse, in that we have sine wave square. So basically we have completed that. So these are used in logic circuits, so that we are getting zeros and ones or analog signals. Those things are coming, just the inputs that we can say. So where to use that? The coming inputs has to be applied some logic so that we can able to produce some out. So for that we have called the logic circuits or the logic gates. So let's see what is the importance of the logic gates or circuits. Let's assume we have a fan. So that fan has to be run. So how fan knows that it has to be run? So if it runs also, what direction and what RPM it has to know. So for all these things we have to write a code in the computers, and we have to set pre-built codes. So write the logic code to run the fan by help of digital circuits. So in that many thousands of chips will be implanted. So with that we have to write a logic, so that the fan has to rotate in the anti-clockwise, this much RPM it has to rotate. After clicking the buttons it has to increase the speed. These are all things we are going to known by the fan before itself, in the manufacturing sector itself. So let's see what are the basic gates that we are going to see in the upcoming videos. So the first gate is AND gate. So the logic and things get truth table logic that we are going to see in upcoming videos. Let's know what are the basic gates. So we have total 7 gates. In the 7 gates, these are the main 3 gates, that is AND gate, OR gate, NOT gate. And extra these 2 gates are all known as universal gates. So with the help of these 2 gates we can able to build any of the circuit we want. So with these basic 3 gates also we can able to build any circuit we want. So but what is the difference between these 3 and these 2? So if you don't have these 3 basic gates, with the help of only these 2 we can able to build many circuits. So the same logic that is built with these 3 gates can able to build with the universal single gate. So that's the main use of universal gate. Other than that universal gates, we have another 2 gates called XOR gate and XNOR gate. So we will be going to see in the upcoming videos in detail every gate, each and every gate, their truth table and their explanation and their full circuit as well. So this is the basic circuit that we are going, these kind of circuits we are going to see in upcoming videos. So how with the help of logic gates we are going to build a complex circuits like this and big circuits. With that circuits we are going to build some output logic. So as you seeing there, the input is an A and B. So output we are getting as A bar dot B plus A B bar. So you might be confused what I am doing here, how that in bar is, what is meant by bar. So bar is nothing but inversion. So 0 is converted to 1, 1 is converted to 0. So that is known as bar. So bar can be obtained with the help of NOT gates. So NOT gate has only one input and one output. So these and all things will be seen in the upcoming videos. So let's have a quick overview what the digital circuits can able to do. So these are the things that digital circuits can able to perform. We might know some things, but let's see all things now. So in the digital circuits we can able to perform the logic operators, the arithmetic operations like addition, subtraction, division, multiplication. So if you don't know, I have already covered that binary multiplication, binary addition, binary subtraction. So that I am giving in the description box, check out those. So we can able to compare between 2 digits that is both are zeros and both are ones, or one is greater than 0, 0 is greater than 1. These and all thing comparisons can be done with the help of digital circuits. So the next one is encoding and decoding, and next one is multiplexing and demultiplexing. So these 2 points, encoding and multiplexing, decoding, multiplexing, so demultiplexing. So these 4 concepts are very important concepts in the combinational circuits. So we are also going to see the combinational circuits and sequential circuits. So these 2 are very important. So let's go, these are going to be seen in the upcoming videos. The storing of data, that is memory elements. So we are also going to see the memory elements in the upcoming videos. So the last one is counting. So we are also going to see the counter. So these and all things can be performed with the help of digital circuits. So you might be don't know some of the things. So if you follow this playlist, you can able to know the all things, what is meant by individual points. So these are the two things that we are going to see in the digital circuits. So these two are the main sub branches of the digital circuits. The whole things will be done in the combinational circuits and sequential circuits. The operations that I am showing above, that is encoding, demultiplexing, counting and storing, these and all comparisons as well. So these and all things can be performed with the help of combinational circuits and sequential circuits. So these circuits will be seen in upcoming videos. So up to now what I have said is the just overview of what I am going to discuss in the upcoming video. But so we just know about inputs. So that is digital and analog signals. That is inputs. So we also discussed what we are going to see in the upcoming videos, that is logic gates. So that is and not this kind of gates, that we have 7 gates total. So before all this, so that is zeros and ones we are going to learn. So what is zeros and ones and what is meant by binary system, octal system, decimal system, hexadecimal system. So these and all comes under the chapter name called number system. So what are these? So we also see the conversions. So how we have to convert the octal to decimal, decimal to hexadecimal. So what is the importance of octal and individual importance? So without importance, why we are converting? So these have some importance, so that we are converting. So the number system only, these and all things works under zeros and ones. So before diving deep into the logic gates, the full circuitry, so we are going to learn the basics. So the number system, the binary system, we are going to learn in the upcoming video first. So after learning successfully the number system and conversions, so again we are going to see the logic gates, Boolean expressions, and the NAND gates, universal gate, and an XNOR gate, and everything, the gates, important gates we are going to see, and the Boolean algebra also we are going to see in the upcoming videos after the number system concepts. Then we have combinational circuits, and finally we are going to see sequential circuits and memory elements in the final end of this playlist. Thanks for watching up to now. So these are the things that we are going to cover in the upcoming videos. So keep in touch with this playlist so that you can able to go through or follow through these whole concepts.